Okay, this is Unit 3, Lesson 2. So Unit 3 is linear relationships. Lesson 2 is graphs of proportional relationships. So when you see that proportional relationships, think about the line, the linear relationship, goes through the origin, 0, 0. And this activity is a card sort. You're going to get 12 cards, 12 different graphs of proportional relationships, and look at each of those slopes and how they compare, how you write those equations. These 12 cards are going to fall out into 5 different groups. So 5 different slopes, and only one of these 5 groups has just one card. The rest of them have multiple examples in which the scales are changed. So it's going to be the same slope, basically the same graph, but they're going to change the scale. And so you're going to look at those differences. So I figured out the slopes for each one, and I'll go through that again. And I just circled in different colors the slopes that were the same. That allowed me to group them into these 5 groups. And A here is the one that only has one example, so 1/4. And so we'll talk about what it means when you look at each of these slopes and then how you move to the equation, because the proportional relationships makes writing the equation much easier. And here's the example or the model of the equation for proportional relationship. This is from last year, from 7th grade, y equals kx. And this k is the slope. And so when you look at this, you can say that y is whatever k is, that factor of the x measure. So let's say, well, let's go through some examples. Let's say y equals 1/4 x. What that means is the measure of y along the y-axis is 1/4 whatever the measurement is for x, whatever the measure, whatever the value. It's better to say value. You want to get away from talking about lengths because it's going to change the value depending on what they're graphing on the x and y axis. So it's 1/4 of the value of x. So think about this value of y is not very large, and the value of x is 4 times larger. So the value of y is 1/4 the value of x. So this is longer, it's a higher value. And again, get away from talking about longer, just think about the values of it. The value of it is along the y-axis is 1/4 the value along the x-axis. This one, the value along the y-axis is 3 times the value along the x-axis. Now I'm looking at it as lengths as I do this with the cursor, but it's really values that you want to start to look at, and we'll do that in a few moments with the graphs. The next 3, the value along the y-axis is 7/2 the value along the x-axis. So it's longer along the y-axis, so it's a larger value along the y-axis. Actually, it's 7/2 of whatever this x value is. Well, 7/2 is 3 1/2. So it's 3 times longer plus another half of this value of x, whatever that is. This one is 5/2 longer, so it's longer still, but this is 2.5 times longer. So 4/2 is 2 and another half, so that's 2.5 times longer. Y is 2.5 times, and I keep saying longer, but the value of y is 2.5 times more than whatever the value of x is, the number of units of x. So try to think about it in terms of units. Whether it's miles compared to hours, it's the number of units of miles and the number of units of hours. And the last one is 4/3. So 3/3 would be the same value, same number of units, and this is 1/3 more. So this is 4/3 of whatever the number of units is for x. That is the number of units for y. So the number of units for y is 4/3 the number of units for x. So now we're going to zoom in for each one of these. We're going to zoom in to 0, 0, the origin, and look at, in some cases, the unit rate, so how much per 1 unit, or at least the smallest that it's feasible to look at on these graphs. So this one, A, has a slope of this value number of units in the vertical along the y-axis is 1/4. So this is 1 unit. And this is 4 units along the x-axis. Now notice the lengths look to be the same, but the value is 4 times larger along the x-axis than it is along the y-axis. So this slope is 1/4. This value is 1/4 the value along the x-axis. B, this value along the y-axis is 3 times the value along the x-axis. Now this one, each unit is looks like they're the same length. It looks like they are squares. So this is 3 times the length in this case. You can talk about length for this one. 3 times the length along the x-axis, but I still think it's better to talk about units. So the number of units along the y-axis is 3 times the number of units along the x-axis. The number of units along the y-axis in this case, it looks like this goes to about 35, and I know it does because I know what the slope is. And this goes out to 10. So that ratio is 35 to 10, or 3.5 times longer, or 3.5 times the number of units. I'm still saying longer, but you want to say the number of units. 3.5 times the number of units than the number of units along the x-axis. Let me say that again. The number of units along the y-axis is 3.5 times the number of units along the x-axis. So this is 10. 3.5 times 10 is 35. This one is out to 5, and it looks like up to about, oh, this is 17.5. This is also 3.5 times longer. So this goes out to, this is 17.5 units, and this is 5 units. So that fraction, 17.5 over 5, is the same as 35 to 10, which is the same as 3.5 times longer. And we're going to expand these out and look at them in a few minutes. But they're changing the scales on you, making it a little bit harder to see. This one is 1 unit, and this goes up to it looks like 3 units. So this is 3 times longer. So now look at that difference. This value is 3 times the number of units as the horizontal axis. So this goes up to about 3, but this only goes out to 1 unit. It looks longer, but you have to talk about the number of units. So the number of units along the y-axis is 3 times the number of units along the x-axis. This one, the number of units along the y-axis is 5. The number of units along the x-axis is 2. So this is 5 halves. So this is, if you divide this into 2 equal parts, this is going to be 5 of those 2 equal parts. So 1 part, 2 parts. This is going to be 1, 2, 3, 4, 5. If you divided this into 5 equal parts, each one of those would be equal to a half. So here would be 1, and this would be a half. A little bit, I'm sorry. Oh, that's right. All right, so we're going to come back to this. Actually, I divided this. 1 is 1/2 of the 2. So this is 1/2, 2 halves. And so this is 5, which 4 is 4 halves, and then another half. Talking too much here. Let's go on. This one is 7 halves. So this is 7 units, and this is 2 units. So this is 1 unit, 2 units. So this is 2 units, 4 units, 6 units, 7 units. So this is 7 halves the number of units as along the x-axis. So this is 7 over 2. So if you looked at these as halves, this length of 2, looked at it as 1/2, 2 halves, then along this axis it's going to be 7 of those. So this is 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves. Each unit is 1/2. So this is 1 right here. This 1 unit is 1/2 of 2. A little bit confusing, just have to keep thinking about it. This, the value, the number of units along the y-axis in this case is 30 units. Along the x-axis is 10 units. So that's 3 times the number of units along the y-axis. So 30 compared to 10, 3 times 10 is that 30. So notice the change in scales. Well, actually, this is about 10. So this looks like the scales are about the same. So this is 3 times, in this case, you could talk about 3 times the length, but again, it's better to talk about the number of units. So the number of units on the y-axis is 3 times the number of units along the x-axis. So this has a slope of 3. This one goes out to 100, looks like about 125, I believe. And so this is 5/4. So 125 over 100 is like having 5 quarters out of a dollar. So this value along the y-axis is 5/4 the number of units that there are along the x-axis. So notice it looks like the length, it looks like this is longer, but the number of units along the y-axis is actually more. It's 5/4 the number of units along the x-axis. All right, so let's look at the last couple of these. Let's look at how it's changed from what we used to do to what we're doing now. And what we're doing now is actually simpler. It's actually easier. Before, you had this slope triangle shifted. Let's just shift it along the x-axis for this example. And we're going to leave it right on the, we're going to leave it on the x-axis, but we're going to shift it along the x-axis 6/10 of a unit. So in this case, the y-coordinate is the same as the number of units in the y along the y-axis. This is y units. That's the same as the y-coordinate. So here it's y minus 0. So this is y units, which is the same as this y-coordinate. So this has just been shifted, or actually it hasn't been shifted at all. It rests along the x-axis, but it's the x-coordinate is in the x direction that it's been shifted. So this is x minus the 6/10. So the value, the number of units in the horizontal direction is x minus 6/10. So you have to subtract that 6/10. But over here, once you have a slope triangle that goes through the origin 0, 0, then the number of units along the x-axis is the x-coordinate. So this slope, this ratio of the vertical distance to the horizontal distance, the number of units along the y-axis to the number of units along the x-axis is y over x. It's the coordinates, y over x. In this case, it's not the coordinates. It is for y. Y is the coordinate because it's not shifted up and down at all. But the x, the value along the x-axis is x minus that 6/10. So this is harder. This is what we're doing now, which is actually easier. So if you see the relationship going through 0, 0, all you have to do is think about the coordinates. You don't have to think about shifting at all. Let's look at another example, see if we can make a little bit more sense out of this. So this triangle now is going to get shifted in 2 directions. The length, not the length, the number of units along the y-axis are these units right here. To figure out that value, you have to subtract 300 from that. So you have to shift it down to here, subtract that 300, and to get the value, the number of units along the x-axis, you have to subtract this 20. You have to shift it over here and subtract the 20. So that's going to be y minus 300 to shift it down, and x minus 20 to shift it over. That would be that ratio is going to equal the slope. Whereas down here, it's already been shifted. This is an equation that's proportional. It goes through 0, 0. So all you have to do is look at the ratio of the y value, because that is the number of units along the y-axis, compared to the x, the value for x, the x-coordinate, because that is the number of units along the x-axis. So it's a lot easier dealing with proportional relationships. You just have to look at the coordinates. And the last example is, it's already been shifted, or it already rests on the y-axis right here. So it just needs to be shifted down. So that means that the x-coordinate is the number of units along the x-axis. It's this coordinate right here, which in this graph is 2 units. So the x-coordinate is 2, and that is the number of units along the x-axis. But the y-coordinate is not y. You have to subtract these 4 units to shift this down. So the y-coordinate is actually going to be y minus 4 over x with this slope triangle here. But notice, once it goes through 0, 0, all you got to do is look at the y-coordinate and the x-coordinate and write that ratio. That is equal to the slope. So these are a lot easier to work with in that way. All right, so let's go through each of the cards. It's going to be lengthy. 12 cards to go through. I'm going to go through the slope for each one of them. So this slope is a value of 2 units along the y-axis, 1, 2, and 8 units along the x-axis, 8 units. So that ratio, 2 to 8, is 1/4. So what that means is that the number of units along the y-axis is 1/4 the number of units along the x-axis, and that's true. 2 is 1/4 of 8. So you can write that equation. I didn't write the equation, but we did earlier. So y is equal to 1/4 x. This one, the number of units along the y-axis is 3 units. The number of units along the x-axis is 1 unit. I could have gone out to 6 units over 2 units, but that simplifies to 3 units over 1. So the length, the number of units along the y-axis is 3 times the number of units along the x-axis. So this equation is going to be y is equal to 3 times x. Y equals 3x, because y is 3 times longer than x. This one, y is 7.5 times longer than x. So notice along the y-axis goes out to 175 units. Along the x-axis, it only goes out to 50. So you have to look at the number of units. Don't get confused by the length. So this this number of units is 7 halves times the number of units in the x direction. So think of quarters for just a second. 50 cents is 2 quarters. That's 2 halves. So $1, 100 is going to be 4 quarters or 4 halves. This 75 is 3 more quarters or 3 more halves of 50. So that adds up to 7 halves. So 7 times 25. So 7 quarters is equal to $1.75 or 175. 2 quarters is equal to 50 cents, or 2 times 25. The 25 over 25 cancels. That's equal to 1. So you're left with 7 halves. So the value along the y-axis is 7 halves times the value along the x-axis. This card D is the same. Different scales, so these graphs are going to look different if you set them side by side, because they're different scales, but they are the same graphs. So the value along the x-axis is 70 units. The value along the y-axis is 20 units. So the value along the x-axis is 7 halves. 70 over 20 simplifies to 7 halves. So it's 7 halves of the value along the x-axis. That's 3.5 times longer. Not longer. 3.5 as many units along the y-axis compared to the number of units along the x-axis. So 3.5 times 20 gets you out to 70. 3 times 20, 60. Half of 20 is another 10. That's 60 plus 10 gets you to that 70. Just a few more. So different scales, but this still has a slope of 3. So the number of units along the y-axis is 3 times the number of units along the x-axis. Even though it looks shorter in length, the value, the number of units, is 3 times the number of units. This is 12 units. This is 4 units. 12 is 3 times greater than 4. 3 times 4 is equal to 12. So the number of units along the y-axis is 3 times the number of units along the x-axis. So just keep saying it over and over again, and you get used to it. You start to understand. The number of units along the y-axis is 5 units. The number of units along the x-axis is 2 units. So that is 5 halves. It's 5 halves the number of units along the x-axis. So if you divide this length into halves, so that's each one unit is 1/2. This is 1/2, 2 halves. Well, this is going to be 5 of those units, or 5 halves. 1/2, 2 halves, 3 halves, 4 halves, 5 halves. So the number of units along the y-axis is 5 halves of the number of units along the x-axis. So if x is 2, the number of units along the x-axis is 2. The number of units along the y-axis is going to be 5, because 5 halves times 2 equals 5. So you can practice going through that, thinking about that. This is 7 halves. So the number of units along the y-axis is 28. The number of units along the x-axis is 8. That's 7 halves of 8 is 28. Well, 1/2 of 8 is 4, and then 7 halves, 7 times 4 is 28. 7 of those halves, 7 fours, is equal to 28. So this length along the y-axis, the number of units along, and I keep saying length, but the number of units along the y-axis is 7 halves times the number of units along the x-axis. So 7 halves of 8 is equal to 28. Take 8 divided by 2, that's 4. 7 times 4 equals 28. This is out 10, up 30. So the number of units along the y-axis is 30 units. The number of units along the x-axis is 10. That's 3 times this number of units. So the number of units along the y-axis is 3 times the number of units along the x-axis. 3 times 10 equals 30. So keep saying it, keep practicing. This is 4/3. The number of units along the y-axis is 400 in this case. The number of units along the x-axis is 300. Well, 400 is 4/3 of 300. If you take 300, divide it into 3, divide into thirds, each third is 100. 400 then is 4 of those thirds. So the number of units along the y-axis is 4/3 the number of units along the x-axis. So 4/3 times 300 equals 400. 4/3 times 300. 300 divided by 3 is 100. 4 times 100 then is 400. Got to keep thinking about it. Keep trying to do it. The number of units, so this is decimal values, but it doesn't change. The number of units along the y-axis is 5 units, 5/10 in this case. We can call it 5 units. That's 5 halves more than the number of units along the x-axis. Number of units along the x-axis is 2/10 or 2 units. On the y-axis is 5/10 or 5 units. That's a ratio of 5 to 2, or 5 halves. So there's 2.5 times more units along the y-axis than there are along the x-axis. So 5 halves times 2 is equal to 5. So you take this 2/10, divide it in half, that's 1/10. And there are 5 of those 1/10 going this way. So the number of units along the y-axis is 5 halves the number of units along the x-axis, which is the same as 2.5 times more. The number of units along the y-axis is 7/2 of the number of units along the x-axis. So along the y-axis, it gets out to, go out to 350. Along the x-axis, it's 100 units. Well, that's the same as 350 to 100 is the same as 35 to 10, is the same as 3.5 to 1, which is the same as 7/2. 35, yeah, 3 1/2 to 1, which is the same as 7/2. 7 times 5 is 35. 2 times 5 is 10. These 5s cancel out, they equal 1. So you're left with 7/2. So the number of units along the y-axis is 7/2 the number of units along the x-axis. So if you take 100, divide it by 2, or take 1/2 of 100, that's 50. And then 7 50s, 7 of those halves, which are equal to 50 units, equals 350. 2 halves equals 100, 4 halves equals 200, 6 halves equals 300, and the 7th half, or one more half, equals 350. So once again, the number of units along the y-axis is 7/2, or 3.5 times the number of units along the x-axis. I think this is the last one. Yeah, this is the last one. The number of units along the x-axis is 4/3 the number of units along the y-axis. Oh, I think I said that backwards. The number of units along the y-axis, sorry, is 4/3 the number of units along the x-axis. So 4/3 of 3. So take 3, divide it by 3, or take 1/3 of 3 is 1. And then 4 is 4 of those thirds. 1/3, 2/3, 3/3, and 4/3 would be the 4 units. So 1/3, 2/3, 3/3, and then 4/3. So the number of units along the y-axis is 4/3. It's longer, it's more. Not longer, more units. The number of units along the y-axis is 4/3 the number of units along the x-axis, which is the same as 1 1/3 times as many units. All right, lots to think about, lots to practice. Keep saying it, graph them, look at the equation, keep saying it to yourself. Try to use that same language. Be sure to use the number of units. Don't talk about lengths, but talk about the number of units. And be sure to note the change in scales, how the same slopes, the same graphs look different when you change the scales. There's a lot in this lesson, a lot to think about, a lot to do.